Welcome to day 1A.3. Our lesson today is going to be over segment and angle addition. And so we're going to talk about these things, but you need to remember back to the previous lesson when we talked about segments and angles. Okay, so when we talk about segments, remember segments can have lengths because they have endpoints, and you can measure the length of the segment between those endpoints, the distance from one point to another. And because of that, any kind of numeric value can be added. And so the first thing we talk about is what is called the segment addition postulate. And actually, there's one big idea I want you to get used to as we work on segment addition postulate and any kind of addition postulate. The word postulate in geometry just means a fact that is true without needing to be proven. It's just the most basic fact that is always accepted as true. And so, any addition postulate is going to follow this format. Part plus part equals whole. Part plus part equals whole. So the segment addition postulate looks something like this. Let's say we start with a segment. One endpoint is A, the other endpoint is C, and point B is somewhere between A and C. And you'll see that written sometimes. B is between A and C. Anytime you see that kind of a phrase, this is what your picture looks like. That you have a segment where B is somewhere on that segment, collinear to A and C, between them. And the segment addition postulate is this. If B is between A and C, then we get this equation. The length of AB, this segment, plus the length of BC, it's the other part segment, equals the length of the entire segment, AC. Okay? And we write lengths of segments as just those consecutive letters, AB, BC, and AC. Those represent number value. A and B are not separate variables in this case. If it were variables, we would need lowercase letters. But since they are capital letters, they represent points individually, and when you put them together, they represent the length of a segment. So here's our first example to help practice this. Suppose that B is between A and X, and Y is between B and X. Okay? So this is a little bit of a complicated picture to show you, so I'm going to show this out. B is between A and X, Y is between B and X. There's actually 4 points here. So here's A, and B is somewhere between A and X. So the next one that comes over is B, and X is somewhere after that. And Y is between B and X. There's X, and then Y is somewhere over here. So B is between A and X, and Y is between B and X. You always want to try and draw this out first. Okay? And so then they start to tell you units of length for these segments. When it says BY equals 9.2, that means the length from B to Y is 9.2. The length from A to X is 32.2. That's that entire thing. Okay? All the way from A to the end of your segment is 32.2. And from Y to X is 12.7. Okay? And so we would draw that. This applies to all 3 of these examples. Okay? And so the first thing we want to do is find the length of AB. So we're asking about that length first. How long is it from A to B? Well, all I have to do is understand this fact. That this question mark from A to B plus 9.2 plus 12.7 equals the total length 32.2. So to figure out this unknown AB value, we just subtract. We do 32.2 minus each of these. Now you can combine these together first. And that gives you 21.9. And so to figure out your unknown value there, We subtract that 21.9. Remember back to algebra, solving equations. 32.2 subtracting 21.9 gives us that AB is about, or not about, is exactly 10.3. Okay? Now they want you to find the length of BX. Well, we kind of already did that. To find the length of BX, we added those together, which is my 21.9. There we go. And now to find the length of AY, we're going to take the answer for AB, which was 10.3, and BY, 9.2, and add them together, because this part plus this part will equal the whole thing from A to Y, giving us 19.5. And so as we go on to example 2 on the next page, we're going to do the same kind of problems, but now we can use some algebra to write some expressions instead of actual values like we did in the last example. So, on example 2, we are told that A, B, and C are collinear, and B is between A and C. That's very much like what we originally wrote. So we're going to draw that each time. There's my segment AC for the whole thing. Because B is between A and C, B goes somewhere in between. It can be closer to A, closer to C. It doesn't matter for this problem. So you are always going to be given pieces to fill in. So if they say AC, you need to recognize that's from A all the way to C. That's the whole amount. Okay, we can write it in like that, put a little bracket showing all the way over to C. That is my 2x minus 6 value expression. Then from B to C is just the value 6. But from A to B is x minus 2. Well, I need you to remember something. We are using the idea that part plus part equals whole. So in each of these cases, we have a part, and a whole amount. So that's your whole amount, the 2x minus 6, so that's what everything is equal to. So I'm going to set up an equation and solve that equation and use my answer to find what they ask for. So one part is x minus 2. That part plus my other part, 6, equals the whole amount, 2x minus 6. And if you don't show your diagram, you're not going to understand which the parts are and what the whole is. Now we go back to remembering our algebra skills on how to solve an equation with a variable on both sides. The first thing you need to do is combine like terms. Negative 2 plus 6 gives me positive 4. So on the left side, it's actually x plus 4 now. And on the right side, it's still 2x minus 6. Then we need to subtract x from both sides, giving me a 4 on the left, and then just x, 2x minus x is x, and minus 6. Then you can add that 6 to both sides to get your answer that x is 10. But that's not the final answer. They ask you to find AC. That means the length of the segment AC. So I'm going to go up here and write AC equals, and I'm going to take this expression, 2x minus 6, and replace x with 10. Oops, don't need that last parentheses there. Well, then I just multiply. 2 times 10 is 20, because we have to multiply before you subtract. Remember PEMDAS. 20 minus 6 is 14. And so as we continue on to the next example, our picture is going to look the same, and I'm going to make it a little smaller maybe this time to give myself more room to work. But we're told still that B is between A and C. That means my picture needs to look like this again. Then we start filling in the different pieces that they've given me. BC is actually this portion, the second part, 4x plus 1. AC is the entire thing, so that's 6x minus 1, and AB is just 2. So these pictures aren't necessarily going to be drawn to scale. They're not going to look like the numbers fit, but we don't need them to. We're just trying to identify a relationship so I can write an equation. So the next step is to write my part plus part equals whole equation. Part plus part equals whole. Well, one part is this 2. That's the first part. Plus the other part is 4x plus 1. And the whole thing is 6x minus 1. Again, we combine our like terms. This side becomes 4x plus 3. Everything else stays the same. We can subtract the 4x from both sides to combine those like terms on the other side, because you have to cancel it by subtracting since it's positive. But then you also can add 1 to both sides if you want to combine your steps. Those cancel, leaving you with 4. These cancel, leaving you with 2x. So to finish solving for x, we need to divide by that 2 to cancel it out. So we get x is 2. But that's not the final answer because they want you to find BC. There's more. So we're going to go back and we're going to plug into this. BC is 4 times x plus 1. So we're now going to do 4 times 2 plus 1. 4 times 2 is 8. 8 plus 1 is 9. So your final answer is that BC equals 9. And so as we continue, angle addition postulate is going to work the same as segment addition postulate. Okay? So it's set up a little bit different though. Okay? And I didn't leave you a lot of room to write this next part in, but it's still a part plus part equals whole scenario. In an angle, let's say I had this, where this top angle was angle 1. I'll use a number system, it's a little bit easier. And this bottom angle below it is angle 2. And then the angle formed by all of them we're going to call angle 3. That means the measure of angle 1 plus the measure of angle 2 equals that total measure of angle 3. So as we look at this, a lot of times we won't have that numbering system for the angles. So we're going to look at number 1. Now remembering that in the example I gave you here, right there, this angle 1 is one part, this angle 2 is the other part, and the angles all together, that big angle combining them is angle 3. That's the whole part. So we're still following that part plus part equals whole kind of theme. So here we've got some information. I've got these angles I've put together. All of these angles have a common vertex of I. That's why I can't call any one of them angle I. The first thing they tell me is the measure of angle JIH is what we're supposed to find. Well, JIH, that's the whole angle altogether. Okay, I'm looking for the whole amount. So here's what they give me. I'm going to redo that. I'm going to erase some of this. They give me that the measure of angle JIW, that angle is 25 degrees. So I'm going to write in 25 in that angle space. They also tell me that angle WIH, W back to I down to H, that angle is 100 degrees. Well, these two parts, 25 plus 100, give me the whole amount. Part plus part equals whole tells me that my entire angle then is just 125 degrees. So the measure of angle JIH is 125 degrees. Okay? Again, make sure you're correctly identifying the parts and the whole. Number 2, this time they want us to find x, finding the value of x. Anytime it says find x, it means solve for a value, a number, answer for x. What does x equal that would make the situation true? So as we look at this, we've got the situation and we're using measure of angle EDR, so I'm going to trace that, EDR. That value is the expression 3 plus 30x. And we're going to use these expressions quite a bit. These algebraic expressions involving numbers and variables are going to start replacing just actual numbers. They also tell me the measure of angle RDC. RDC, that's this other part, is just 55. And they also give me this. EDC, that's the whole angle. And I'm going to come out here to kind of give you that bigger arc there. That's the whole amount, is 59x. So again, if I'm doing the model of part plus part equals whole, I'm going to fill in the pieces that I have. Well, one of these parts is the CDR, that's 55. The other part that I have is the 3 plus 30x. And it should equal the whole expression, 59x. Well, there's an equation with an x in it, and we can solve that equation for x and find our answer. So what I want us to do then is just start combining the like terms. 55 and 3 becomes 58. There are no other x terms on the left, so that stays 30x. The right side is 59x. Okay? To get x by itself, when x is on two separate sides of the equal sign, remember that you want to cancel the x on one side so it moves over to the other. In this case, I'm going to take the smaller one, 30, and subtract it so that I don't end up with nothing on one side of the equation. So those cancel there, leaving me 58 equals 29x. And then the last thing we want to do to get x by itself is to divide by that 29 to cancel out 29 times x. And this seems kind of strange, but you should recognize that 58 is just 2 times 29. So 58 divided by 29 is 2. And that is all I had to find here. They just wanted the value of x. So that's my answer. Okay, let's keep moving right along and finish out these examples. Example 3. Again, another similar problem to what we just had. You're told the measure of angle HMN, that's one of the parts then, is x plus 87. One of the other parts is LMH. LMH, that's x plus 68. And then they also give you the whole amount expression, or in this case, the actual angle total for both of these put together is 149 degrees, meaning this angle is 149 degrees. They want you to find the measure of angle LMH. So that's this angle measure. So not just x plus 68. Once I know what x is, I'm going to add 68 to it to get my angle measure. So if I set up part plus part equals whole, one of the parts is x plus 68. The other part is x plus 87. And the whole amount is 149. We want to combine like terms again. X plus x becomes 2x. 68 plus 87 is 155. Bring down your 149. And now we would subtract the 155 from both sides. I'll just plug that in my calculator. 149 minus 155 is negative 6. Do not panic when you see negative numbers. That does not mean you've done something wrong. It just means you have a negative value we're using. There are certain times when negatives will not work for us, but in this case it will. We're not done though. We still need to divide by the 2 to get x by itself. Negative 6 divided by 2 is negative 3. So I do get a negative value for x. X is just a variable. X could be any number, and so negatives will still work for that. But when I plug back in, if I were to get a negative angle measure, that would not work. We can't have a negative angle measure. If you're using segments, you can't have a negative length. So I don't want to plug in a negative there and get a negative. But if I plug this in for what they ask for, LMH, which is that expression, measure of angle LMH is going to be that negative 3 for the x plus 68. Well, that's like doing 68 minus 3 then, which is just 65 degrees. And so my angle measure that they ask for is 65 degrees, which is still a positive number, so it works. Okay, here's what I want you to do. You'll notice this does not give you a picture on number 4. What we're going to do, I'm going to show you how to draw the picture given the information they give you. But then I'm going to have you pause the video and try and solve the problem after that on your own. So this says point I, that's the letter I, capital letter I, lies on the interior of angle KLM. So I'm going to draw angle KLM. Just going to draw a large angle. Put K up here. L has to be the vertex, remember, and M. And it says I is on the interior. So I, some point I, is on the interior. That means inside this shaded region. Now I'm going to shade it. You do not have to do this on your notes. This is the interior of the angle between those two different rays that extend out. They don't tell you if they're rays, lines, or segments, so we can kind of draw it how we want it. Now you don't have to have it shaded, so I'm going to erase that part, but that helps you know where the interior of an angle is. Now they tell me some information here about like angle KLI. Well, that means I need to connect L to I with a ray. And then you see that it's a problem that looks a lot like the last 3 examples. So the measure of angle KLI is 88 degrees. That's this part. The measure of angle KLM, that's the entire whole amount, is 14x plus 9. And the measure of angle ILM is 3x plus 9. Now, I may not have drawn this to where it fits for the actual angle measures. That's okay. You don't have to. All we're doing with the drawing is setting up an equation. So before I can find the measure of angle KLM, I need to find out what x is. So this is a part, and this is a part. So when I do part plus part equals whole, I write 88 plus 3x plus 9 equals the whole amount, 14x plus 9. And then we start simplifying. We combine like terms here. 88 plus 9 is 97. Okay, then I start by getting my variable to one side, so I subtract 3x from both sides here. That gives me 11x plus 9 equals 97. Subtract 9 from both sides. 97 minus 9 is back to 88 equals 11x. Then we should just be able to divide by 11, and you should recognize pretty easily that x is 8. But we want the measure of angle KLM. KLM is the whole amount. So I'm going to plug back in here. So the measure of angle KLM is 14 times the value of 8 for x, which gives me 112 plus 9, because 14 times 8 is 112. And when I add 9 to that, that gives me 121 degrees. And so the answer I get is 121 degrees.